additional video to try to help doing homework 5 in spring of 2021. And we're going to do work through example 14.4 in the book and make a spreadsheet to try to organize our work right here. So we open up this blank thing, and the first thing we should do, let's save it as a file name right here, right? So I think it's really important that you do this in every class. It just makes sense to put like the year, the semester and the year, the course number, and what homework it is right here, and then put your initials or name. I'll put mine Deal right there, and then I'll also, and here I'll also put what it is. This is example 14.4. Now I'm going to know, like years from now, when maybe I keep all these files, what it was here for, what it was doing, and then anything I send to somebody, they're going to know what it is right here. Hopefully I'm going to have enough time because there's only 30 minutes until class. So let's hope I can race through here. So let's put our name right here, Dr. Deal. What did I say that we should do? Dr. Deal. Dr. Deal homework 5 example 14.4. Maybe I've even put the S21 ME470. Might as well, right? So I'm going to switch back and forth between the book. Here is the example here where we have 17 teeth, 40-degree pressure angle. Spur gear rotates at 1800 RPM and transmits 4 horsepower to a 52 tooth, right? So there's 17 going to 52. The pitch is 10, face width is 1.5, and the quality is a number 6. The gears are saddle mounted with bearings immediately adjacent. The pinion is grade 1 steel with a hardness of 240 Brinell. Tooth surface through hard canes. The gear is steel. So it's a different one, but it's grade 1 material with a hardness of 200 and a tooth surface and core. Poisson's ratio is 0.3. JP, so they gave us these JPs and JGs. Normally we would look them up, right? So I don't know why they did that for us. We could have looked them up. It's got a modulus of 30 million PSI. The loading of the tooth, the motor and load assume a pinion life of 100 million cycles and a reliability of 90. And then it tells us which of these equations to use off of that graph right there, right? So they figured some of that out for us. The tooth pro is uncrowned. It's a commercial enclosed gear. We're going to try to find the factor of safety of the gear in bending and the factor of safety of the gears in wear, and by examining them, identify the threat of which one is going to go through here, right? So we know what our mission is, so let's go ahead and put this up in here. All right, so it's 4 horsepower, 20-degree pressure angle, and I should mention once again, I use this color coding for this is given, calculated, something to look up, and then something guessed. I'm saying guessed here because we're going to use the spreadsheet to try to estimate go backwards using goal seek later on. So the pitch is 10, face width is 1.5, the gear has 17 teeth, the pinion has 17 teeth while the gear has 52 teeth. I don't need to use this line right there. I just liked putting it in there. I don't even know why it's still in there. Maybe we should remove it. We said we had 1800 RPM right there. So you can see that already some of these things already worked out for you. Here's the diameter of the pinion, diameter of the gear worked out. In here, I left it as through hardened steel. This is really just a comment right here, but we have 240 is my Brinell hardness for that. 200 is Brinell hardness for here. I want E to the 8, right? So 1E8 right there. My size factor. Let's see, for this one right here, I actually used a size factor, right? So trying to keep in with what happened, what they were using in the example. I would say normally just use a 1, but if I was going to keep with what's in the book, so you don't have to follow along with this, but if we want to get the same value as is in the book right here, we would use the equation which shows up to be equation, I believe, equation A in section 1410 right there, right? So if we were going to go to this and go to the size factor, which I said not to, and by the way, we're going to get 1.043 and 1.042 if we do these correctly right here. So coming back in here, that's this equation right here. You'll note what is y? Where did y come from? I think y is yeah, do they use yeah, I think they are. Interesting. What do they say in the example? I need to hurry up as part of this. I need to be more efficient here. But yeah, okay, no, they looked up the Lewis form factor, right? So that's why I had the Lewis form factor in my original one, so I didn't need it back over in here. But if I look it up, I have a Lewis form factor of 0.303 for the pinion and 412 right there, right? So coming back into applying this, that's why I had it up here. Like, it wasn't needed though. It's not going to be needed because we're going to use 1 for the thing, but we had 0.412 up into that gear. And so if I go to this equation right in here, I say it's 1 point, oops, I need to say equals 1.192 times this thing where I got that face width, right? Well, actually it needs to be times a parentheses right there, and that's times the square root of this right here, square root of that divided by this again, right? And then close and raise to the 0.0535. Okay, so this was not a necessary step for you, but if you want this to match up with the example so that you can set up your spreadsheet correctly, you would put that in there. And then once again, that is the thing that we were trying to get. Let's see, did I get the number to match up? I did not get the number to match up. So I did something wrong in my... Oh, this is supposed to be divided by the pitch right there, right? So that right there was supposed to be the pitch. Boom. Okay, so now it matches up. Boom, boom. And I'm going to go ahead and copy that equation by highlighting it inside, highlighting it like inside here. Like I highlight it up in here and go Control C. And then I'm going to place it over to here. And now I'm just going to change the location of that over to here, right? So now we get 1.502 and 1.502. Right. So our goal is just to get these things to mesh up. The JP that was given to us, we could, though, also have looked it up inside this right here. Right. So in this page right here is where we would have looked up that J for the pinion, but they gave it to us in the problem up above. So we'll type him in 0.3, and then right in here. We'll have 0.4. I already have my equations placed in there for these standard ones here, but you'll see that they gave them right in here. But You want to make sure that you're using them correctly. So you want to double check that your situation is correct, and that's really for some where you have more cycles than 10 million. So is anything greater than 10 to the 7. So I have some kind of phone call coming in from Canaan, Connecticut. I don't know. They're going to ask me about my car insurance warranty or whatever the hell it is. So let's see, coming back here. And okay, so we go to KO, and as according to the, they make a decision that they're going to assume that it's uniform loading. So KO is equal to 1. If it wasn't uniform, we would be using this table down here for that KO. But we'll set it equal to 1 because they told us so. The quality, they told us it was 6. Right, so I've already set up this A and this B for you. We want to go to the KV, so that is an equation you have to enter in for the dynamic factor. And that equation is right here. So we're going to use, we have our V already calculated at the top. So we're going to take that A right there, and we're going to place them in there. So, let's see, I'll place that right in here. We're going to say equals to parentheses A plus square root of V, which is right up here. Close that for the parentheses, close this for the other parentheses, divide it by A. And then close, okay, and then raise to the B. Kaboom, 1.377, and that agrees with the dynamic factor that we will get out of the book somewhere right there. Boom, 1.377. Okay, so all of this mess I've decided to bypass. And I'm just going to write in, if I'm given, right, this KM. In the book, it is discussed right here, where we start going through the thought process for all of these right in here, right? And then we bring them all down, and we get 1.22. So and in fact, I think if you do them correctly, you'd get 1.220, so it's fine, right? 1.22 is fine. So I'm going to put that right here, 1.22. The rim is, we're going to say that's 1 because there's no rim. For the temperature, we're going to accept that as 1 because it's all right. We had a reliability of 0.9, right? So that we need to look up in a table. And so that table is table 1410. And so we have 0.85, right? So we have 0.85 right here. And now here's the longest one that you're going to have to calculate for, right? So this is going to be the allowable strength that you're going to find for the thing. Oh, maybe it's not the longest one. Let me take that back. So, oh no, okay. So we're gonna calculate that for an equation that shows up out of the book right here. So for when we get to the strength right here, we look up from table 14.3 for grade 1 steel, and they tell us to use figure 14.2, right? So this is this is the process that you should be going through for the homework. So if we go to 14.3, and what we end up saying is we need to use figure 14.2, and I think for this one, you see, we're using 14.2. And we're going to use one of these two equations. Which one do we decided we use? We decided that it was grade 1? Grade 1 steel. So yes, we are using this equation right here with the 77.3, right? 77.3 times the thing. So let's put him into place here, and equals 77.3 times, and is the hardness, which I think was written up higher, right there, plus our 12,800, I believe. And yes, you should be getting 31,350. I think they rounded off in the book. And I think we do the same thing. I'm going to copy it from there, put it into here, but now we're going to move the hardness over to there. And yes, we get 28,260, which should match the book. We could be hopeful. Matching the book. Yeah, they're slightly. Yeah, no, we get the same thing. Okay. Okay, so where else are we? Where are we at right now? We want close this problem down. Close it down. All right. So so far, okay, we could actually see that we have this whole thing set up. I've actually done the stress calculation for you right in there. I really shouldn't do this stress calculation for you. You should do it. But that is, so maybe I should leave that out. I think I meant to leave it out. I guess I'll leave it in. I don't know. But it's all those, it goes back to this formula right here. See, I think by leaving it in there, I'm giving you too much. But I want you just to walk through that. That right there is this equation right in here. But if you work through the examples right in here, if you work through this right here, you should get that 6,417 right here. That's our goal, to make sure that we have everything set up the right way. So I really should be getting rid of that. I really feel that that's like doing too much for you, right? So let me get rid of that and get rid of these. And I only have a couple of minutes left until class, but we will say that we're going to work through this equation right here, so that we can at least have to have the experience of thinking our way through the thing. So we say equal to, and I almost want to write that equation somewhere right here. So let me pause. Here's the equation right there. Blow it up so we can look at it as we're writing this thing out. So we say the stress is equal to WT, boom, times my KO, boom, times my KV, which is right there, boom, times my KS. Where'd you go, KS? KS, where'd you go? Oh, you're right up here. Size factor, times my pitch, boom, divided by my face, I said force, multiplied by my KM, multiplied by my KB, and then divided by my J. And I get the 6,417. And if I'm a little bit lazy, I copy that all over, boom. And the only things that change, everything is the same. This factor, that guy, that JP comes to the JG, and I don't think anything else changes. So did we get the 4,813? Let me double check right in here. I'm going to see my other side over here. No, I made something different. What did I do differently? Not sure. Oh, my size factor. That's it. Size factor had to change. Of course, that won't be different for most of us, right? So, where are we going on here? We want to change. I see it's trying to do that. Okay. Change this right here. Change the size factor over. Boom. Now we should be getting the exact same thing as the book right in here. Right. So we're going to start class in about 9 minutes. We have to get in here. So there's actually, where did I cut? No, I see. I'm calculating on the spot. There you go. 4854. Okay. And let's see, we're going to continue on. So we got the same thing there, and we can see that we got the same, I'll leave this thing in the same, this is the allowable right there from those equations, and then we're going to get the same factor of safety. So so for the pin, so right here is a factor of safety, little difference, 6.82. I get 6.83, I think. And then we also have the 5.62. So those are slightly different, but no big deal. Now we want to do the same thing for over here, the elastic coefficient. All right, so that's going to be 2300. We look that up. Surface condition factor, 1. The face ratio, that's 1 as well. Let me get rid of this equation that doesn't need it anymore. I worked all these things out for you. The hardness ratio, you know what? I left this as 1 for mine. What they did is they went through a process right here for the hardness ratio where they get this and then they put it back in and they get 1.005. I do have that as part of the spreadsheet, and I'm kind of wondering why I do like to get up right up to there. I don't know. I kind of just want to put 1 in there for right now, but I think you can calculate the thing out with that equation. Like I said, I'm running out of time, but I also don't want to just be skip over this right here. Okay, so here is where that shows up. So if you wanted to get it to be identical right in here, and of course we said that they're the same in here, you say that it's going to be equal to 1 plus this A prime times the gear ratio, which is right there, minus 1, right? And so if we did it right there, you get there's our factor right in there. So the allowable stress, contact stress, that for them is comes from right here from figure 14.5, and we've used this 322. So let's double check where they got that from. That comes from this right here. So they use the table, they carefully think it through, and they used with the information given, and they decided that was the correct equation to use back in there. So we go ahead and do the same thing here, and we say that it's going to be equal to, let me take a peek at this. What? Oh, no. I want to say it's equal to, what's going on over here? I don't know what this guy is doing to me. Okay, this is what that guy's doing to me. Wow. All right, so what happens when you panic? You don't panic is what the Hitchhiker's Guide to the Galaxy tells you to do. So that's going to be that times that plus 29,100 right here. Boom. And I'll reuse this, but the hardness changes over here. So you can see what the effect of the hardness is going to be. And then lastly, we take this equation right here, plug it in, and start populating this thing with what we know. We're going to say equals CP times the square root of WT times KO times KV times KS. Remember that, so the size factor is going to make something different for this. Most of the time, not going to change for us. KM, which is, we don't use much. Diameter of the pinion, and this is always the diameter of the pinion, divided by the face width, right there, and multiplied by CF, and then divided by I. And we're going to close that. And let's see if we got the right one. Let me see, compare it to my previous work, 7331. Sure enough, it also should compare with what's in the book right here for stress. 7360. It's pretty close. And now if we just copy this whole thing over and modify, I think only the size factor will change. Let me see if I got the right. Yeah, pretty close. And then now you can see we got pretty darn close to all the other numbers that are in here. We get 1.69 and 1.52. We're golden. Got to go off to class, but I thought this would be a good tutorial to include. It took 27 minutes.